All right, welcome everyone. Okay, this particular sets of notes, we're going to be doing single transformations of quadratics. So let's go ahead and begin. Now, I'll be honest, I know that they show you a lot to do this by hand, but please keep in mind that the calculator is a great tool and you are welcome to use it to do a lot of this. So what we're going to be doing today is we're going to be using our knowledge of transformations, and that's what that's supposed to be, that's just a little typo, to write equations and then graph quadratic functions. So you'll notice that this one's not quite as long as the other one, so let's go ahead and let's begin. All right, and so in the previously we've looked at the functions and we've graphed it using a t-table and all that. So now what you need to know is that when you're transforming a function, the graph of a function, you're modifying it by either inverting it or flipping it, you're translating it or sliding it, or you're dilating, which means stretching it within the coordinate plane. Now, those are all terms you should remember from geometry because you do transformations in geometry, okay? So the equation of the parent function describes how the graph of the parent function changes. Okay, I'm sorry, the equation of the quadratic function describes how the graph of the parent function changes. Keep in mind that the parent function is y, or f of x equals x squared. Okay, so let's go ahead and do one. Okay, so now you see that we have the parent function there, and we've already done this one. Okay, and so you're going to plug this in, so graph it, and then we're going to look at kind of what happens here. Now, one of the things I want to do here is I actually am going to pull up the graphing calculator because I want you to see what it looks like as we change it, because I think that might help a lot of you. So I'm going to pause here for just a minute and get that set up. So just give me a minute. Okay, welcome back. Thank you for waiting. So, which you probably didn't feel like you were waiting at all, but you know. Okay, so here you have it where they just graphed it. They did a t-table. You did it. Okay, so the first thing we want to do is look at the parent function. The calculator that I'm going to show you on, this is actually the TI-84 plus C silver. So it's the color grapher because I think it's very visual and it's going to really help you there. So I went ahead and I went into the y equals key and I just graphed y equals x squared. And then I asked it to graph on, as you notice, I'm on a standard window. And so you see where the graph is, so you can identify the vertex, and you know that this is the axis of symmetry because it is cutting it in half. Now, what I would like you to see, if you go back here, now if you invert it, that's when a is negative. So notice I just put a negative out in front of my function. Um, and so when you do that, let's go ahead and graph that, then you're going to actually see what that looks like. Okay, so now let's do that. So we're going to do negative x squared. Okay, and then I'm going to ask it to graph again. Now, as you see, this is what the negative x squared looks like. So this is inverted, and that all I did was put the negative in front. And so what's nice here is you can see this is your parent function, which is just x squared. And then I put the negative in front, which all that does is it forces it to flip it or invert it. So it now opens down, okay? And like I said, I wanted you to see this because it's so colorful and it looks so much better, okay? So then let's go back. You know how to do that. One of the things I do want you to notice is that the same vertex is the same, the axis of symmetry is the same, because all I did was flip it over. Okay, so now let's go through the next one. Okay, I paused it because I didn't want to hear all that in the background. Okay, so now we're going to do some vertical translations. And so notice what you see here. It occurs when adding or subtracting outside of the squaring function. And it does exactly what you think it might do. So adding 2 will move the parent graph up 2, and subtracting moves it down. So now you're going to see what happens because I'm going to put both of these on the graph. Okay, and so let's go back to y equals, and I am going to shift this. I'm going to put in, okay, x squared plus 2. Alrighty. I'm going to leave the negative, so I want to go back here. And all I want to do is just unselect it. I don't know that I want to delete it. Let's go back. Okay. Okay. So now you've noticed that it's unselected. Guys, this is how you can do it so you don't have too many things, but I don't want to get rid of anything. And so let's ask it to graph. So I just want you to see the difference between the parent function, okay, which is what it always draws first because that's what I entered first. Now I want you to see the other one. And so notice that if I add 2, I shift it up 2. Again, does exactly what you thought it would do. Now I want to do it where I want to show you where we've actually, let's shift it down. Okay, so now we're going to do x squared, and we're going to subtract 3. But notice I left the add one, okay? And why does that look like that? Okay, I have no idea what that did. But this is the one I want you to look at, okay? So notice it took it from the parent function and it shifted it down 3. Okay, so notice you can put a negative out in front of the function and that forces it to invert or flip down. You can add a number to the whole parent function, in other words, to the x squared, so you can shift it up or you can shift it down just by whether you add or subtract. Okay, so let's go to the next piece. All right. Again, this is the same thing. We're going to shift it. Now, this one's a little bit different on number 6 because you're going to constantly see what we're doing. And then, of course, you can see the vertex and all of that. Okay. So now, what I want you to see, though, here, we're going to make it negative. So I inverted it, and I'm going to shift it up. Okay. That's literally what you're going to do. So if you were doing this by hand, you just take your parent function and you flip it over, and then you shift that up once you flip it over. Here, you take your parent function and you're going to shift it down 5. So everything shifts down, okay? So let me show you on the graphing calculator because, again, I just think it looks really cool because you can see all the colors and it really does make a difference. Okay, so I'm going to go here and I'm going to go over and I'm going to unselect that one. Nope. Okay. Enter. Oh, well, let's unselect it. Okay. Now we're going to enter and shift that down. Okay. Now we want to use it was, sorry, I forgot, negative x squared plus 1, I think. Let's go. Yep, negative x squared plus 1. Okay. So we're going to have negative x squared plus, okay, and none of that's registering. Negative, oh, well, that's why. Okay, let's try that again. Sorry. Negative x squared plus 1. So now keep in mind, we're inverting it and from the parent. So the first thing again is going to draw the parent function because that's your pair comparison. That's where you start. Okay. So it turned it over, but it flipped it up. So if they just flipped it over, the vertex would have been here. But now not only is the vertex not here, but then it shifts it up. So your line of symmetry is still the same, but notice that your vertex is 0, 1 instead of 0, 0. Okay. And so again, that's when you put a number in front, or basically A, you make A negative, and you add a number to it or subtract a number to it, okay? Whoops, yep, there we go. So let's keep going. Okay, now here's a horizontal shift. So now when you do that, that's when you're changing x, not x squared. Okay, so what we're going to do here is when you change x, what happens is it's kind of the opposite of what you think. I think we can get rid of that. But anyway, so when you add 2, it shifts the graph left 2. And when you subtract, it shifts the graph right. The reason for that is think of this as x minus a negative 2. So that's why it's shifting it left. And then this is minus, so 4 is plus. That's why it's shifting it right. So we're going to show you how that looks. So give me just a second. And again, this is where you actually change x. Okay, so let's go back to our graph. And let's go back to y equals. And we're going to go down. And again, I'm leaving all these in so I can just unselect them. And here. And then we're going to go down. Okay, so the only one you're still going to see now is the x squared. So I'm going to put both of them in, and then we're going to talk about that. Okay, so you're going to have open parentheses, x plus, I do that every time, don't I? Okay, so open parentheses, x plus 2, close your parentheses, x squared. Okay, and then open parentheses, x minus 4, close your parentheses, x squared. Now, keep in mind, if you kind of forget, you're going to see the colors next to it, okay? So I went ahead and put both of them on because I just wanted you to see. So again, it's graphing our parent function, okay? Now this one is the x plus 2, so notice, again, remember it's like x minus a negative 2, so it shifted my graph left 2. And then this one was x minus 4, which makes it positive because it's x minus a number. And so this one shifted my graph to the right 4. So if you want a horizontal shift, you actually change x. If you want a vertical shift, you change x squared. Okay, that's where you're looking at. So let's keep going. And like I said, I think this is very helpful. Let's go back and let's look at that. So you notice the vertex here, when you shift it left, this was the y equals x plus 2 quantity squared. Notice my vertex is 0, negative 2, and my axis of symmetry is now x equals negative 2. Notice that this function was x minus 4, y equals x minus 4 quantity squared. So we shifted it to the right 4. So notice that my vertex is 4, 0, and that my axis of symmetry is x equals 4. Okay? So hopefully you're seeing this, I think, because the visual is just, I think, so powerful here. Okay, so let's see what else we got. Oh, we're doing good. Okay, and so let's do that one. Okay, so again here, we're going to shift, and then we are going to invert it. So you know it's going to flip it down, and then it's going to shift it left 3. Okay, on number 10, it's going to leave it as it is, but it's going to shift left 5 because this is x minus a negative 5. That's what you kind of have to think about it, and that to me makes a whole world of difference where you're shifting. So from here, if I were doing this by hand, and then you can fill it in, I want to show you, because the graphing calculator is great, but I know that all of you don't have one. So I kind of want to show you how this is going to work. So let's do a pen. Okay, so this is where the x would be if it were just y equals x squared. So I want to shift it down, so it's going to do this, but I want to take and shift this 3 to the left. 1, 2, 3. Okay. And then so this would be here and here because I turned it over. So it's opening down. Okay. Now this one, I'm taking it, it's still going to open up, but I want to shift it left 5. 1, 2, 3, 4, 5. So here and here. And that's what it looks like when you shift it there. Okay. So again, your vertex here is negative 5, 0, and then x equals negative 5. Here it's negative 3, 0, and x equals negative 3. because again, I'm not shifting up or down because I'm not changing x squared, I changed x. Okay? That's what it looks like, guys, when you do it by hand, and it's not hard. You just have to remember everything. So now, here what we're looking at is dilation. So we're making it wider or more narrow or just, whatever you want to do. So here's some things you need to know. So we need to look at what happens when the absolute value of A is less than 1. When the absolute value of A is equal to 1, and when the absolute value of A is greater than 1, okay, and what it does to the graph. So I'm going to copy a few, and then we're going to show you. Okay, so notice we have y equals 1/2 x squared, and then we have y equals 2x squared, okay? And so I'm going to compare those two. So let's go back here, and again, you can do this by hand, but I think this is a little more powerful. So I'm going to go back to y equals, and what I want to do here is I'm going to get rid of some of these. That's all I'm going to do. So I want to clear. Let's go up. I want to clear. Go up. Clear. Go up. Clear. I'm going to pause this. Okay, so now we already have the x squared in, so now let's put in 1/2 x squared. If you have a Casio, you're just going to do 1 fraction key 2 x and then the x squared key. On the TI, sorry, you're going to do parentheses. I'm going to do 1 divided by 2. I'm going to close my parentheses, x squared, and then enter. And then here I'm going to do 2x squared and enter, because I want you to be able to, again, comparing to the parent function, which is y equals x squared. So then you can kind of see, and then we can fill in the chart. Okay, so there you go. Now, this is the 1/2. So notice 1/2 makes it wider. So when it's less than 1, it's wider. So guess what? When it's greater than 1, let's see, yeah, less than 1. And then when it's greater than 1, which should be, yep, that's the 3. Okay. Okay. And then when it's greater than 1, it's more narrow. Okay. Okay. And then what do you think happens when it's just 1? It's the parent function. Okay. Okay. So when it's less than 1, what did we decide here? And let's go ahead and fill that in. Okay. So when I'm just waiting for this to catch up with me. Okay. So when it's less than 1, it's wider than the parent function. Okay. When it's equal to 1, it's the same as the parent function. And when it's greater than 1, it's narrower. I never can say that right. Than the parent function. Okay. And so you saw that. And then you saw the vertex stayed the same. The axis of symmetry stayed the same. Okay. And guys, again, this is all about looking at A. Okay. And determining what it does. So let's go here. And guys, that's actually it. So please feel free to watch this one again and again, because it's honestly not difficult. You just kind of have to keep up with what you're doing and what happens when you change different numbers, okay? So thank you, and see you on the next video.